Wave Basics by Liat El-Kayam. A sound wave has a frequency of 262 Hz and a wavelength measured at 1.29 meters. What is the speed of the wave? How long will it take to travel the length of a football field, 91.4 meters? What is the period of the wave? Some key words that we can use are frequency, which is the number of waves that pass a given point per unit of time. Wavelength, that is in the symbol of lambda, is the length of one wave and is measured in the form of meters. The last key word is period, which is the time it takes for one wave to pass. What is the speed, or what is the velocity of a wave? The equation that we will be using is v equals lambda f. The lambda, which is the wavelength, is the 1.29 meters that we were given before, and the frequency is 262 Hz, which was also something that we were given before. So we put v equals 1.29 meters times 262 Hz. The answer we get is v equals 338 meters per second. The units for speed or velocity is meters per second. The next problem we have is how long will it take to travel the length of a football field that is 91.4 meters long? The equation that we will be using is t equals lambda over v. T is the time, lambda is the wavelength, and v is the velocity or speed that we got before, which is the 338 meters per second. So our equation will look like this. T equals 91.4 meters over 338 meters per second. The answer we get is t equals 0.270 seconds. The units are seconds because when we have meters on top and meters on bottom, they cancel out. So the only unit we have is seconds. Our final problem is what is the period of the wave, or how long does it take for one wavelength to pass? So the equation we will be using is t equals 1 over f. T as in the period, and then f is the frequency that we were given at the beginning of the problem. So our equation will look like this. T equals 1 over 262 Hz. The answer we get is t equals 0.00382 seconds. The units for period are always seconds, just like in time, because period is a type of time. Real-world applications. An example of a transverse wave, which would also look like a sound wave, is the way a snake moves. It wiggles from side to side to get around and to move. An example of a longitudinal wave, like a sound wave, is how a worm moves. It coils together and then spreads apart to get to places and to move around. I hope this was helpful, and thank you so much for your time.